Welcome, everyone, to the fourth and final roundtable regarding Map 3D. So, we want to do a lot of case studies and as well build some venues from scratch. As we know, Map 3D is available since August 19th, and that means that you have had ample time to play with it. And for all we know, that might have provoked some questions. And to answer those questions, we thought it would be nice to make ourselves available to answer those questions, which we've been doing in a series of 4 roundtables. And that means that during those roundtables, any of these fellow Meyersound colleagues are likely to join us. Today we have Steve Bush with us, as well as Alex Harbo. We also have some Mexican colleagues with us. I can see in the list of participants. Welcome to Guatemala, and I saw Oscar. Awesome that you're here. And today we will be joined by the venerable Bob McCarthy, our Director of System Optimization. All roundtables that we've conducted so far, episodes 1, 2, 3, are all available on our Thinking Sound YouTube channel. So if you haven't seen any of the past roundtables, be sure to subscribe to our YouTube channel, and then you can see all the previous roundtables at your discretion. And as always, we would like to remind you that the primary support platform is the dedicated Map3D help website, which is under continuous development. Be sure to visit the help website. It contains animated GIFs as well as video clips. The website can be found by either visiting map3dhelp.meyersound.com or by simply clicking on help in the main menu bar of the Map3D application. And that means that today's topics, as announced, are going to be how do I start a project from scratch? And we're going to look at some case studies. And that means that Alex Harbo and Bob McCarthy will have the honors of doing that today. And we're going to start with Alex. So, Alex, at this point, it's all yours.
So the first example case study I wanted to show was a very simple system, an overhead distributed system, similar to what you'd see in retail or corporate settings, just basically a grid of overhead speakers. But I wanted to show how we can look at that in Map3D and put that together very quickly with array tools and checking coverage. So right here, I've kind of just set up an arbitrary flat plane with a standing head height listening plane offset of that. That's the blue plane sitting up here. And I also have a microphone, but I don't have any loudspeakers in here yet. And this would be kind of if I walked onto a site and I knew the general length and width of the space, and I wanted to start talking to an installer or something and work out an overhead system on the fly, or just to do it quickly, either way. So I've gone to plan view. I'm going to pop in a single loudspeaker. And let's do a UP4 Slim. And let's rotate that to be pointed down. And let's say for this example, let's pick a 7-meter mounting height of this loudspeaker. So I'm going to put 7 meters in here, and just arbitrarily to start off with, I'm going to put it in a spot where I'm just going to check the coverage in the middle of my audience area. So I've got my speaker up in the ceiling and my audience plane. Let's go to the top view and let's do a prediction. So this is the default SPL settings in Map 3D. And right away, I can tell this isn't super useful information for me to start off with. So I'm just going to change my SPL. And let's go to the attenuation setting. And let's look at 3 decibels per color to start off with. So once I change that here, I can start to see this first 0 to -3 decibels is right here in this dark red circle. And then the -3 to -6 SPL is the next color ring. So when I'm doing an overhead system, I want to have that coverage overlap at the -6 point, right? So what I'm going to do is measure the distance from one side of -6 to the opposite side of -6. I'm just going to use my free draw tool here and just draw a line. And it's going to be on the ground, so you won't see it on top of the prediction here until I turn it off. And we can kind of check that distance. It looks like we're going from 8.6 to 16.6. That's easy math. That's 8 meters. So my 6 dB down coverage is an 8-meter circle, right? So what I want to do is make a grid of these UP4 Slims at an 8-meter spacing, right? So I'm just going to get rid of that measurement. And just so it looks nice on this rectangle that I've drawn here, I'm going to change the coordinates of this loudspeaker. I remembered 8-meter spacing, right? So if I half that in the X and Y, that's going to put this speaker right in the corner. and that coverage, half of that circle is going to meet these walls. So I'm going to take this speaker, highlight it, and let's go to the array tool. So I'm just going to do a simple rectangular array. I know my spacing was 8 meters. So I'm going to go 8 in the X and Y. And I'm just going to kind of eyeball. I think this is going to be 3 in the Y. And let's say 5. Let's do 5 and go in the X and see if we get to the end of the room. So boom, it looks like we might not need this 5th row. We could probably grab all these and shift it, which I'll show you in a second. But let's go back to the plan view and just do a prediction of everything to check how that coverage shakes out once we've got the full array of overhead speakers going on here. So if we're looking at 3 dB per color, we have our 0 to 3 here as we looked at earlier, and we have down to -6, but what we can see is this is poking back up once those coverages start to overlap into another color up. And specifically, once we're more into the middle of the room, that summation is extending between those loudspeakers. So we know we have a good spacing and we'll have fairly even high frequency coverage here, at least within our design variants. So that's overall gets you pretty much your spacing and gets you some predictions to kind of show your work essentially. If we did want to move these as one group, we would group them, right? So I can go to edit and group these guys together. Oh, I have the microphone selected. Just put him out of there and then group these guys. So now all those speakers are grouped together. If I wanted to move them as a group to fit, say, a ceiling grid or to start to coordinate with architecture, this can make this a little easier. You don't want to drag them completely out of the room like that. But that's my first example, just a simple overhead system, how you'd look at coverage with the SPL, the different ways we can look at SPL in Mapp 3D, arraying and using the grouping tool to move these guys around if we wanted to coordinate these into a ceiling grid or something.
All right, I'm going to unmute, and I'm just going to ask Alex to go through the measurement, that little measurement trick to that you used for the spacing.
Sure. There's 2 ways you can do this. I use the free draw tool for this one because I don't have anything to snap to in this case. If you have an imported DXF or an SKP file, or you have actual elements, objects like geometry drawn for your room, you can use the measuring tool up here to snap to vertices or midpoints of any of that geometry. But since I really only have a rectangle here, I'm using the free draw tool. So let's just do one more speaker again.
Alex, do you think it's cool to, rather than having 3 dB per color divisions, that we use our quick design settings with a range of 12 dB and 6 dB divisions like we discussed during previous roundtables?
You can absolutely do that. And I was going to share that on my next one, but yeah, let's look at that. So let's change how we're looking at this SPL and make it a little more refined and filtered, essentially. So we're going to change the range of that SPL from 42 decibels from 0 to -42 on that attenuation scale. We're going to shrink that down to only 12 decibels. So we're really going to see from 0 to -12, and then it's going to be black, and it'll basically be off. We'll know we need something to help there, or maybe we didn't want coverage, and that's where we want the coverage to end. And then with that 12 dB range, it's kind of a useful tool to make your resolution of the colors that your SPL is showing to be 6 decibels per color, meaning your prediction's really only going to be 2 colors. It'll be your 0 to 6 and 0 to 12, and then nothing. So it's really a pass-fail of, does this meet my primary 6 dB variance in coverage? Beyond that, you can see where you need help or where you're going to need a fill rather than, say, a delay, for example, in a theater PA.
And Alex, you ungrouped your array, right? So that you could single out the one speaker.
That's correct. Yeah, I did a prediction thinking I was going to be one speaker, and I forgot I'd grouped them all. So all of them predicted. So yes, I did just ungroup those to get back to one speaker. So we have the old crimson and blue prediction here. We are at 6 decibels per color. So what we had looked at earlier when we were counting 2 colors, we only need 1 color, and that's this red color. So if we were to measure the width of this red dispersion at the listener height, I've just selected the line that I measured that red with right here. And I'm going to, do some math between those X measurements of, let's call this 15 and let's call this, 22 and a half. So that would be 7.5 this time. I think last time was 8. So either way, we're within half a meter of what we did last time. And that's probably down to the resolution and the randomization of the prediction. If we turn everything on, it should be a big red coverage of within 6 dB everywhere, except where we have some interaction, but these are in real life probably small enough to not be noticeable to the average listener. Yeah. So overall, we see everything's red, and we can start to see where our coverage dies off right at the edge of the room where we might not want sound to go.
So for those viewers that are not familiar with this technique, be sure to watch the second roundtable where we discuss this at great length. Thank you, Alex.
The next example I wanted to show, I'm going to build on what we just looked at by looking at coverage with different SPL ways. We're going to use similar techniques, but in a different setting. We will also look at how to combine different types of loudspeakers. Like we're going to look at a main and delay for a theater here. So this theater is an actual project. This is a 2-level theater with a balcony. And let's see, the previous design had an array in it, but I want to remove that. Let's take out the old speakers and start over. Okay, so for this system, let's just put together kind of a simple speech reinforcement system. We're not going to try to make rock and roll with crazy subs, but let's just get high frequency coverage to every seat. Let's use our tools we just looked at for the overhead systems to kind of apply that to more of a speech reinforcement theatrical kind of setting. Let's just start with a single center flown channel. I'm going to insert a loudspeaker system. And let's start by looking at a single X42. So I'm going to put this X42 as if it were horizontal, and I'm going to use the 7-degree horizontal horn rotation, which is the 50 by 70 setting. This first number is always the shorter top side of the loudspeaker. And let's put this in here, and let's put this up to a reasonable height because we just put that on the ground, right? So let's move this up here. And I'm just going to aim this arbitrarily kind of. But let's look at our coverage. First, let's go to our SPL settings. Right now, these are the last settings I used, I think, on this project. But let's go to attenuation, and let's look at the 3 decibels per color again, because this is kind of my standard setting, either this or the 6 decibels. So let's just predict this speaker, and let's look at 4 kilohertz. All right, so I can already see just based on this that my coverage is not wide enough. So I'm either going to look at more loudspeakers to help that or a different loudspeaker. And that's probably the first thing I'm going to do is maybe the X40 will give me that horizontal coverage I need. But overall, I'm seeing that 50 degrees is almost enough coverage for this location I just arbitrarily picked. I might pan this down a little more to try to get those front rows. Let's swap about this because we knew that horizontal coverage was not quite wide enough, and let's see if the X40 gets us there. So we're going to pick the 50 by 110 version, which is the rotated horn of the X40. So let's predict that, and wow, that did the trick, right? Our 3 dB coverage goes all the way across the room, and if we think of this first darkest red color as 0 to -3 in our variance, we're going from probably like the 3rd row to almost the 3rd to back row, and then we're counting down from -3 to -4. We're not even getting to the next color. So I know I'm within from here to here my target SPL variance. And this right here, I would say is probably the front row. I'm going to rely on maybe some additional SPL for some front fill here, or I could adjust this even more. But either way, for a center channel, this single X40, I can tell from this prediction is going to hit the room, at least the main level. But I can see up here, I'm going to need some help, right? So that's the main thing I wanted to look at next, is putting some delays up in here. So let's pick a spot. If I had architecture to go off of, which for this room, when I'm actually doing the design, I do, but I didn't want to show it publicly. I'm just going to pop a delay speaker. Let's call it right here. And for this one, let's use a UP Junior. And we're going to keep that rotated. And just to say, these express settings I use all the time when I'm needing to aim loudspeakers and using the arrow keys to do this kind of aiming. Just, I found it to be very quick. So I've got a delay on center aimed at about second to back row. Let's see this prediction. And one thing I'm going to anticipate with 4K and UP Juniors, having used Mapp for a long time, I know 4K isn't necessarily the frequency I want to look at the UP Junior with to determine what the overall high frequency coverage is. Specifically on the UP Junior, because the crossover point is into or very close to this octave that I'm looking at here. So typically with the UP Juniors, I'm going to look at 8K. And that'll give me a more accurate representation of the 80-degree coverage that we have above that crossover. So from here, I can see, looking at the 3 dB per color in attenuation view, once again, I'm doing pretty good at 8K. So let's go to the 6 decibels per color. And let's just crank that range down to 12 again, so we can see our pass-fail for this delay speaker. All righty. So I'm going to measure how wide my 6 dB down point is on this. And basically, we're finding where we want these speakers to stitch together at. So I'm going to measure from here to here, because I want these to stitch together maybe the second row of this balcony. And let's find that free draw I just made. And so we went from positive 3.1Y to negative 3.5Y. So I'm just going to call that, let's call that 6.5. I can already tell just visually that I'm going to need 3 delays, right? I might be able to pull it off with 2, but just for this example, I'm going to do 3. So 6.5 was my spacing for these delays. So if I know I need 3, I'm going to move this one to negative 6.5. And I can already see that's a little too far out, right? So let's just move this to negative 6 or even 5.5, because what we're going to plan on is panning this loudspeaker out a little bit to meet the curvature of the seating. So I'm going to move this to maybe, let's call it 10 degrees. And I went the wrong direction, so let's get a negative 10. All righty. And now I'm just going to copy this 3 times, and I know my spacing. Let's stick with since I moved this away from the side wall, let's go with the 5.5 spacing, so my center one ends up at the center. So I am going to have 1 row and 3 columns in the Y of this loudspeaker. And we're going to go 5.5. It's going to give us 3 loudspeakers, and we can just fix these pans pretty quickly. So now we can predict all 3. Boom, we are red all in the balcony. And after this point, I like to kind of start to look at this a little more granular to really see where my coverage might be doing some interaction and things that 6 decibels might not have shown me. But overall, I can still see with my 3 dB per color that I'm still really good. And I can hopefully get a little bit of SPL from that main loudspeaker to help tie these together and source to that main speaker, which from the predictions I saw, that front of the balcony was getting some of that main loudspeakers dispersed.
So Alex, before we go forward,
Yeah.
we have a question from Hidenori, and Hidenori is wondering whether you could elaborate why 8 kilohertz and not 4 kilohertz. He noticed that you mentioned something about the crossover.
We can look at 4 kilohertz. Again, the UP Junior, specific to its crossover point between the low and the high frequency elements of that loudspeaker, that crossover point is, if I recall, around 2.5 kilohertz. And if we're looking at the octave centered at 4 kilohertz,
3.5. That's why it's trouble for 4. It's at 3.5.
There you go. It's right up in there. So yeah, if I show you a 4 kilohertz prediction again, and let's turn this on to the very high res so we can see as much as we can with this.
Basically, when we're aiming speakers, we want to be in the custody of the loudspeaker, in the frequency span where we can see whether we're aiming the speakers right without any interference in the handover between the transducers. So if that handover lifts too high in frequency, you're going to see lobing throughout crossover, which is inevitable. But it doesn't help us in aiming the speaker. So we want to go high enough so that we're no longer in the shared custody of the low frequency transducer and the high frequency transducer.
we used to call this the kind of skeleton hand coverage, where if you are expecting even 50 or 80 degrees coverage and you start to see some weird kind of thumbs on the coverage, that's when you can kind of see, all right, I was expecting 50 or 80, but not really narrow things with side aberration. So that's when you might look at the next octave or a more granular range of bandwidth. There's our example of a dispersion and resulting coverage that I'm not expecting, and I don't want to make decisions based on this coverage, essentially. So I'm looking at this and I'm just saying, I'm not going to make decisions on this. I'm going to look at something else to really try to get a nice coverage of.
If you were to go to 24th octave or some super high resolution at 4 kilohertz, it would be much more well behaved. It's a composite of 24 measurements of 24th octave. 4K is already starting to get in the clear, but 3500 is where it's really cloudy. See, it's already starting to widen out.
Yep, so it's starting to pull it up together and just have one element make that.
Exactly.
So those are my quick demos of how I kind of approach design with looking at SPL and using the array tools to determine spacing and using the array tool to make arrays of loudspeakers that have consistent coverage, either in an overhead system or a fill or delay system for a more performance PA. I would do this for front fills, underbalks, any kind of distributed system this is super useful for.
So, Alex, I was wondering if we want to do this slightly more sophisticated at the expense of more time, is this something that we could also do with a polar array?
Absolutely.
And then put your pivot point all the way upstage?
Yeah, the challenge of that right here for me to do live would be knowing the angle that we wanted to start and end at.
Right.
So
but if you really want to track that balcony edge or stay parallel to the balcony face, then
with a little planning in the CAD and measuring that, or if in future tools we have a measuring, angle to help that polar array tool, which is a feature I've requested, that will be a lot easier to say, all right, if I start here, I need to have this speaker end at 20 degrees from there with a rotation point of -20 and put 3 elements across that arc, essentially. That's really easy once you know your start and end points, or if you're just being able to cut it off, like with the geometry. But yeah, with actual arrays, it takes a little bit more preparation, essentially, to get that ending point, or a lot of guesswork and trial and error. So this is my quick way to kind of eyeball and measure coverage versus measure geometry specifically.
Let's go to Bob.
Okay, get ready to slow down. Okay, I am not going to design from scratch. I'm going to take you into some places that exist that or hypotheticals that exist, but that I've already done some work on, and we'll sort of walk through. This is a real place, and you can visit this place someday. And it's called the Pearson Theater. It's at our home in Meyer Sound in Berkeley, California. Some of you may already have been there, and some of you might be actually in the factory right now. And it's a small theater. It was originally designed. We were told it was going to be the great place for us to do seminars. So all of the chairs or desks and all this. We did 2 seminars, and then it was taken over by Constellation and cinema people, and that was the end of that. So it's a really great cinema space and Constellation space, and so that I'm going to show you how we would design that for a modern immersive system real quick here. So this listening plane it's a kind of a funny distribution. It's a rectangle, and then king and queen seats on these 2 spots over the doorways. So this is essentially where we are going to try to hit. We have a main system that's in the front, and those are called the Asheron speakers. And I use pretty much exclusively this 12 dB range with 3 dB per color. So my feeling is if you can't get it within 12 dB, I don't mind it being black, because that means it's effectively in, if you read my books, you're in the isolation zone. So you're effectively uncovered. So this is a case where we have the speakers, and I can give you a little section view to see where you are. We're shooting straight ahead, straight out, and there we are. The height of these speakers is not optimum for coverage. It would be actually a little better for me to raise them up, but it is for the cinema, wants them in this range for the cinema imaging. And so that's where they are. And so what you can see is that normal laws of physics are applying here. As you can see, it get quieter as we go deeper into the room. The left and right are coming in, and I've got this one. This is at the more traditional type of aim, and this is at the super immersive aim where we're crossing over to the center. So the difference there, not a lot, because it's a wide enough speaker on a very narrow piece of real estate. So it's really not going to make a big difference. That's your main system, but let's get into the side surrounds, because that's where this sort of where I came in to do some design work. We wanted to look and see if we can make a completely immersive system that goes around 360 degrees, and that's what you have here. And so if you start from here, you're handing it off from the mains, and you have to climb up the hill. Remember, if you look on this section view, you can see that we have to climb the hill. And so my aim is, all the way right now there. Let's see if I can show you this guy. We can see where he's aimed. There he is. Okay, so you can see he's aimed at the top of the room, right there. I've just aimed at the top seat. And that's, to me, facing a steep rake like that, I'll take my chances that I'm going to miss the front. Let's take a look. And I'm going to shoot that speaker again. And you can see I obviously didn't overshoot the front of the room. So you can see you've got a bit of a challenge there, and we could do a little better. Let's try to raise this speaker up. So I'm going to go up a meter, and now I will re-aim the vertical. Whoops. And okay, so I'm going to go up one, and here's my vertical, and I'm coming, instead of plus 4 degrees, I'm at straight 0 degrees, and we'll go back and take a shot at that. And I'm getting a better response. So as long as this isn't too high from a image point of view, we want this to be a side surround, not an overhead surround, then we're okay on that. So then as I go around the circle, you can see, again, we're running into the same thing, and I'm just going to rise this thing up, and I'm using the program to be able to tell, and I'll just bop it down a couple degrees, and I'm able to get a little more. Now I'm going to go up to 4 meters, and I'm going to see where this gets me. But then we're going to measure and make sure. I better get better. Yes, you see, I'm getting way better, but now I've got to do a little test here and make sure I still qualify as a lateral surround. So what I'm going to do is I'm going to aim this speaker 45 degrees down. And when I aim it 45 degrees down, I'm going to get rid of the rear surrounds just to decrease traffic. And you can see my speaker. I'm going to zoom in. What I'm looking to see is my speaker still on the people? And so there it is. So I'm going to move this speaker, and you're going to see that's the point where there it is right there. 51 degrees is where I am right now at the edge of people. Well, I guess if you technically call my edge of people on the chair 38 degrees, haha, so I made it. So the reason I go for these numbers is that if you're at higher than 45 degrees, then you're really kind of more overhead than you are to the side. If you're below 45 degrees, you're more to the side than you are overhead. So this still technically qualifies, not in the aisle, but on the person's armrest, but on the person's head, I'm still okay. And this is a funny application because it's one where the room is so small that you can tell the difference in angle between the armrest and the chair. So I'm going to go ahead and go back to my 4 degrees down or whatever it was and predict this again. And I'm going to tell the people there that because this is, I worked with the sort of parameters that were given. And of course, right now you can see I'm stuck inside of a bar. You see that metal bar that I'm on? That's the hanging bar. We're going to have to talk to somebody about that. So my next stop up would be 4.5 meters. Probably I'm clear of the bar. Oh, I'm on the wrong speaker. 4.3. Yeah, I'm inside of a bar just fine right now. And yeah, no structural engineer has to get to work now. And mistake, I've just predicted everybody. Okay, so there you go. Now you can see I've got really good immersive coverage. I'm covering virtually everybody in the place. So I'm going to go ahead and preemptively move this up. And now I got to show you a kind of a fun thing. This is a fascinating little piece of information for you. If you take a look at this speaker, you can see there are 3 parameters in play. And I'll bring it up to the 4-meter spot. Well, I'll leave it here right now for the moment. So you see that it's turned 15 degrees on the yaw. Okay, so if I go to the normal 0 degrees, that's what you're going to see is that I'm going to get a response, and that's like what we normally think of in a speaker. And you see it's very irregular because it's hot here and then it's cold there. It's bigger off axis to the center of the speaker than there. Well, what's the reason of that? Reason of that is a speaker facing straight on a target that's moving on a slope. So what you see that if I bend the speaker to the slope, then you're going to get a better response. So here I go, and I'm going to bend this thing 15 degrees, and there it tilts.
Bob, I think in your book you refer to that as Smileys and Frownies.
That's a smiley and a frown. That's a special case because he's got a really irregular facial expression because he's smiling on one side of his mouth and he's frowning on the other from this point of view. So it's a tweaky thing, but what I've done is because of the fact that it's a 110 by 50, it's a speaker that has a very different pattern in the 2 dimensions. So I've got to bend it to make it essentially coplanar with the shape that I'm covering. So you'll see that each of these has a little bit of has this 15-degree bend on it to go with the rake. And that one, I mean, I hit it real nicely, but if I were to just to hang it like everybody hangs a speaker, just hang it straight, you can see that with no other change, look where it went. It climbed up the hill because the hill is closer to it. The higher elevations are closer to the speaker because the speaker is up. So if you want to get the speaker to come down to the lower places, to me, this is the payoff of the Mapp 3D experience is being able to see this level of detail. And it's always annoying to find out that you missed something for 40 years of your career, but it's nice to learn something too. What can you say? An old dog can be taught new tricks. So that's kind of what I wanted to show you. Oh, here I have some overheads to turn on here. And the overheads are aimed to fill up this space as well. Mostly the center area of the space, we know that the very end of the space are going to perceive the speakers right behind them as overheads anyway. See, think about that. If you're right here in the last row, you don't need a speaker here to be overhead. You've already got one. It's right behind you and overhead. So that's why we bring them inside and then fire away like that. But once again, we are hitting a moving target surface. It's sloping away from us. So we can get some benefit from bending this guy as well. You see how we can get a better spread from that. So these are tricky little things. It's kind of fun to see. So that's what I kind of wanted to show you this Pearson Theater. Anybody have any questions or thoughts or comments on this before I go to another venue?
Hi, Bob. Thanks so much for this amazing presentation. I just wondering when you designed this, I don't know for maybe this specific case, but when you design this immersive environment or surrounding environment, do you focus all speakers in the center or what's a better thing? I usually think about maybe just like evenly cover the seating rather than this focusing in the center.
In a 100% immersive mappable system where we can move the image to all these locations. And so basically I'd have 360 degrees of movement on this plane, and then I could also do 360 degrees here. I like to call it, I can fly helicopters at multiple elevations. I can fly helicopters high, or I can bring the helicopters down low. The principle that horizontally every speaker is aimed as if it's the only speaker. If you ever did my exercising classes I do where I show you one speaker and I show the speaker gets pushed to the side because of the video screen, it's that exercise. So every one of these speakers is made to make the minimum variance. And what I've really used as a target is not the 100% of the space. I have to that's a whole nother subject is the sort of the space map go design philosophy. It makes a square that's smaller here. So that this is not this is given that we can't do full immersive in the last row. So this square is reduced to equal amount missing on the front and on the sides. And so that becomes the target. So this is the center of the space map go rectangle in this case, and everybody is aimed to make that. So if you were to turn on all the speakers at once, that would be a disaster. But the beauty of our immersion system is that if you wanted something panned to the center, it wouldn't turn on every speaker. It would properly run the levels in order to make the summation go properly to the center. So that's the beauty of it. The space map panel will move the sound through there. And so you want to have it be that for every person, the maximum amount of that speaker that they can have, so that as it moves, it maintains the high end as well as the low end. Now, in this case, when you space map against such a steep incline, and you see this speaker I didn't raise up, you can see that it's challenged because the people down here, they would perceive that speaker as dark. And that's, of course, what we don't want to have is we don't want to have anybody be dark. So I get him raised up. This one here is a better example. I've got almost every seat in my zone will perceive that speaker as having a good spectrum. And so then if the sound were to move up to here, which is fairly close in the same, or I should have done that one, but you can see if I move from this speaker to here, I just made a vertical move that see how much many of the people would perceive they'd have the same frequency response and it would just move vertically. So then when I go from here to the next spot horizontally, the helicopter is moving this way, and so many of my people are still having the full frequency response there, and it continues. So that's the principle involved here. It is a truly multi-channel. It's not everybody is an array. It's every speaker for themselves. It's as cowboy as you can get. Everybody's 100% on their own.
Great. Yeah. Okay. Thanks so much.
So
Thank
Bob, we got a question on the chat by Kai, who was wondering how does that aiming work with Atmos?
Atmos uses very similar strategy. Atmos has a couple of advantages over us, and that is always in movie theaters, so it has very consistent shapes. And of course, this is a movie theater, so the Atmos design is pretty close to this. They will bend some of the corner ones back a bit, but it's essentially a true multi-channel strategy. So there's not a lot of daylight between us and Atmos. We do tend to use a smaller quantity of higher power speakers is our strategy. We don't think you need 5-degree granularity. 30 degrees is a really good amount of granularity. You don't need a speaker at every 5 minutes on the clock every hour is more than enough. And that for low frequencies, 45 to 60 degrees is plenty sufficient because of our localization of low frequencies is quite poor, and localization is overruled by high frequency components.
Thank you, Bob. So I think we can go to your next project.
Okay. Well, this is real quick. I'm just going to show you one more of these. I'm going to make it mucho fasto. This is a real live demo that have going in New York. I'm going to go over and listen to content on it today. And this is at a small studio in the Jazz at Lincoln Center complex, and it's a complete immersive system. So you can see this rectangle in the center, that is the prime immersion area, and then this is all the area that's covered. If you look at just this square, you'll see that we have really optimized the coverage. So that's all inside of my zone. And the X40 is such a great tool for this. You can see how well it performs. And then we wanted X20s for this job, I freely admit, but they don't exist yet. So we've got UP Juniors, I believe, but they're narrower, as you can see. But we are covering the whole area within the 6 dB range. We've created what I call the Planetarium Dome. If you look at it this way, you've basically got a planetarium. You've got your helicopter can fly this way where it's perceived as lateral, and it can fly up into the dome, and then it can fly circles around in the dome. And then you can see that we just have 4 locations for low frequencies. So that's all the same principles again. So I'm going to now go and we're going to move to a concert hall type of project. So it's a kind of an interesting shape. You've got a floor that makes sense, just with a rake, but then there's this small second balcony that then gets kind of covered over by, first balcony that gets covered over by the second balcony. So it's a bit of a strange shape. The upper balcony comes and wraps around and blocks off where you would have coverage on the first balcony. But if we look carefully at the first balcony, go to the plan view, and I'll take away the second balcony. And there we go. We see this is the only area where there's seating for the second floor, and then there's seating above for the third floor. So you see you've got a really kind of a strange shape. So we've got a main system, and so let me turn on those planes. Third floor, there it is. You can see now I've got to hit this thing, and so you can see I have a real challenge because it has to wrap around. We can't tell the sound to come here and then come around the bend. My array set is not able to do a kind of a balcony avoidance scheme. So 4, 4, 6, 5, there's a little bit of relaxation as I hit the front of the balcony. And then it goes 4, 5, 7. You can see I've gone back deep again and then opened up wide to the front. So really we're playing a 1 balcony scheme rather than 2. So you see it go narrow, then go a little wide, and then go back again. This is the place where you see that the couple wide angles. And of course, one of the great things about Mapp is that you can predict, and then you can look at different views and things. Now, this, of course, is that sales presentation version where you've got a 42 dB range. So I'm going to go and get down and dirty. So I'm heading to my project settings, go back to my 12 dB, and we're going to see what this thing really looks like. Do we have it covered? And the answer is pretty good. It's pretty obvious, though, we're going to need a right side of the PA. But we did reach to the third balcony. We did die out at the top of the third balcony, which is desired. And we're not too overloaded in the front. And what can we do with that front? Well, maybe we can do a little bit of work on the processing to bring that down. And this is, and you can see I've already got processing in here. So my device is got I've got 6 channels of processing. I'm basically doubling up the speakers. I've got 12 Lena. I'm going 2 boxes per channel. And you can see the processing that I've got going. And I am doing a nice little gentle slope. And what have I got? It go to the U shaping. I'm already at 6 dB. If I were to push this a little harder, I'll go to 7, 5, and go to 6 dB per octave here, pardon me. And I'll just bring this guy down a little more. I'm not going to touch that one. Okay, so I've just basically pushed the processing down a little bit, and I'm going to go back to the model view. I'm going to turn on both sides. In fact, I can do that by just doing this. I really make use of the feature of Mapp that makes these things not see-through, and that allows me to see where my speakers all land and if they get blocked by a balcony, for example. So I'm a big fan of that. And in a case like this, where you have this funny curve, if you looked at it just in 2D, you would conclude that all of these center seats are blocked by this. But the 3D shows that those center seats actually have visibility to the cluster because these arms only come down and knock out the sides, most of which are unpopulated. We have under balcony speakers are also part of this system. As you can imagine, we're going to need under balconies. Okay, look at that now. So we have a couple of these hotspots that are where left crosses right. It's right down the center of the plate. But other than that, if you just sort of remove that, everybody is inside of our window now. That's so that's pretty darn good coverage. I'm pretty happy with that. So that's my main system. I'll show you some other parts of this system. Let's see, we've got things like under balconies. So there's under balconies on the first floor, that's 4 boxes across, and under balconies on the second floor that are just 2 boxes. 2 boxes are only needed here and here. I don't even really need it at the center because I got such good coverage already from the big boys. So those guys, if I shoot them real quick, you'll see, and I'm going to turn off third floor prediction surface for 2 reasons. One, it's not needed, and it just slows everything down. So if I look at these guys now, my intention is to light these up effectively, and this area in the center doesn't need to be covered because it's already got full visibility. So these are where the eclipse starts to happen from the upper area. And so I have an overly spaced system on the lower floor on the first under balcony, which I can turn on now. That's a more traditional spacing like what Alex had described earlier. So they are going to just do a unity coverage emphasizing the last rows. So they're aimed at the very last seats, and there they are, unity coverage there. With a little bit of ganging up in the middle. So I might look at, oh, let's just see it. Let's just take this spacing and I'll take it up to 2.9 and 2.9. And we'll see if this, using the attenuation is, to me, is a really great thing because it everything migrates to the hotspot, and so you design around the hotspot. Now, every once in a while, yeah. Oh, okay. So now we've got an evenly distributed set of heat. So I'm super happy with that. So then there's also a immersive system in this room, and that gets much more complex because you already saw how complex this room is. So if I put on these surfaces again, third floor, the immersive system has got a lot of work for it. Now, this rear surrounds for the first floor are located on the balcony rail, because if I put them all the way in the back, I've got to plow through people to get there and you'll never make it home. So these guys are going to get there to the floor. And this is going to show you a fun little artifact, because I bet you this is going to look terrible. Oh no, it looks fun. Because what can happen is if you're really too close to a surface, like on the balcony rail, it'll light that up, and all of a sudden it'll look like total darkness here because you're right close to a surface. But you can see now, this is the rear surround. I got really good coverage. Here then is my start of my side mapping, and we have really full coverage there. So we're able to do a full immersion on the floor with no trouble. Now, how are you going to do? Oh yeah, then I've got overheads, and so I used a big speaker on the overheads. These are, oh, there they are. Here they are. Overhead is nice and high, so I used a big speaker, the UPQ, whereas these are X40s, so it's a more firepower, but it's a longer distance. But they're able to come down on the floor and light up the full floor. So this speaker alone can cover the whole floor, and as you can see, you're going to be able to do your helicopter all around the floor, and that's going to get the first floor and kind of the second floor, but the third floor is going to have to be covered by a separate system. So you can't be everything for everybody. So they are going to go with another speaker close by and a more traditional unity type coverage. They're going to perceive the sound from overhead, but I can't make it spin around in a circle for these people, because where would it be? Where would the circle be? Right here. So you can see sort of the dilemmas you have when you're facing these complex shapes. So that's the approach. These guys are you've got a planetarium, like I described before, going here. Your planetarium having multiple levels and multiple rakes and wraparound things, that makes it a little bit challenging. I showed you the under balconies, right? Well, those under balconies can also serve a second purpose, and they can essentially be a overhead speaker for the people here. So they'll get, you can bus into the overhead and space map yourself that way.
We have another question from Kai, which is more towards the design choices that Bob makes rather than Map 3D itself. But that being said, Kai wonders whether the compromise of the surrounds is okay for the customer. I think he's referring to the fact that you have a fully immersive experience downstairs, whereas on the second balcony, there's only so much you can do with your overheads.
Right. Well, I'm not saying that customers have realistic expectations, because that's customers can have fantasies, but I'm of the mindset of under promise and over deliver, because telling somebody that in the last row they can have a personal 360-degree immersive experience, well, you better give them a 3D set of headphones, because it's just not fair or realistic. It's foolishness, and it's marketing people might say that. Basically, I look at this particular venue and I explained it to the customers exactly this way, that if you look at this area here, and even this area here has a full planetarium experience. It has full vertical and full horizontal. And then when you go deep under the balcony, even on the first floor, you're no longer able to do that. You have what I call the cardinal directions rather than the granular approach. So think of a cinema which says it has left surrounds, rear surrounds, and right surrounds, kind of the 5.1 approach. So what I have is, if I show you, I'll get rid of the third floor right here. And there are another set of surrounds underneath for that first floor, but they are done in the more traditional manner. Let me get rid of these extra layers. So here you have your traditional rear surround and your traditional side surround. So they're still going to get a side surround experience. They're still going to get a rear surround experience, but there's no way for me to make this speaker reach over to here. It's just not realistic. And so it's as good a surround as we normally would have, say, in cinema or in a lot of musical theater, which basically do side, rear, and that. But what we have is an extra feature. We've gone beyond the normal here, and we've got back to normal, or once you get deep under the balcony. That's sort of the way that I like to sell it. I give you the most immersion that we can really deliver, but you're the one that made, just make your room a perfect square with a flat floor, like our Jazz at Lincoln Center demo, and baby, we can get almost everybody, in the game. But as soon as you start doing curved underbalks that go and start at the second floor and go up to the third floor, you are asking for the impossible dream. So this is a fan-shaped church. It's a very complex shape. And the first thing you'll notice is that I've gone and I've turned off the prediction plane on all the exclusively house left panels. Reason being, I'm going to streamline the prediction process as much as I can. And that's the key thing. It's all about time. So I can still fire up both these arrays and get the fully predicted response, but because I have these turned off, I get a faster prediction, but I'll see the summation of this array at the center.
During the previous roundtable last week, we talked about optimization strategies and how you can reduce the prediction time. And the things that we talked about is that the prediction time depends on several things. Of course, your meshing density, which you set in your product settings, determines the density of measurement points for each active and visible surface area. So by lowering the meshing resolution, of course, speeds up the prediction time. But the other thing that we need to be mindful of is that predictions only apply to all surfaces which are both activated for prediction as well as visible. You can have 900 layers with geometry in them, but as long as they're hidden, they will not be included in the calculation process. And then the larger your active and visible surfaces, the more area at the same density, the more prediction points that need to be made. So as your projects scale up, it is expected for the predictions to take longer because all things being equal, larger area with same density constitutes more prediction points. And then the bandwidth that you're predicting, if you're predicting a wider bandwidth, then you have to calculate more frequencies. Whereas if you're predicting a narrower bandwidth, then you're calculating fewer frequencies. And also the number of speakers that you are predicting. You can have 100 speakers in your design, but if 99 of them are muted, then you're still only predicting a single loudspeaker. So those are the factors that determine your prediction speed.
There we are. There is another system, another downfill system that's going to cover the front. But so the intended area is to cover, you're starting, about 1/3 of the way up the fan, and then there's a fill system to cover the front. But you can see with that main system, we were able to get a really great uniformity across the fan, and also really nice to get it to die off right where the trouble starts. So that's a beautiful thing. I'd love to see the blue just on the fringe edge of the story. And this is where, to me, this is where I prefer the dirty, nasty look, because you go and you look at this 42 dB thing, and I don't find that very compelling. Okay, if I look carefully, I know that means that's in the -12, but that's
50 Shades of Orange.
Exactly. Give it to me straight, baby. That's what I say.
Excellent. Well, Bob, thank you. Thank you very much. Much appreciated. And that means that thank you to Alex as well for doing your presentations earlier. Thank you to Bob for doing his presentations. And on behalf of Meyer Sound, please stay safe, please stay healthy, and best to you and your loved ones. Stay tuned for more information regarding Mapp 3D.